Hi there, welcome back. This is Professor Hank, and in this video we are going to review working with the stack in MIPS. So let's begin. Okay, so the stack is a temporary storage location that is used to back up data, right? It's primarily used by procedures. And the way you manage this thing is by using the stack pointer register SP. Okay, the stack it's kind of weird because the stack grows downwards, which means that when we want to make room on the stack, we're going to need to do a subtraction operation, right? And then when we want to reclaim that memory that's used, we do an addition operation. Okay, so the code that calls the procedures, so let's review the convention here. Code that calls a procedure is going to place the first 4 arguments that should be passed to the procedure in registers A0 through A3. If there are any additional arguments on top of those first 4, well then those guys are going to get pushed onto the stack. The calling code then backs up the argument registers and the temporary registers T0 through T8 if needed. Then it uses the JAL instruction to start the desired procedure. Okay, so the procedure, which is the callee, right, the code that's getting called by the caller code, is going to start its business by creating a stack frame if it's needed. The procedure will then save any of the registers it's responsible for saving. The callee saved registers are S0 through S7 and RA. The procedure then executes its logic, whatever it is that it's supposed to do. Once it's done that, if it has any values to return, places those in registers V0 or V1. The procedure will then restore any of the callee saved registers from its stack frame, so any of its registers is responsible for saving that it did save in the frame, it restores those. Once it does that, reclaims stack memory by popping the frame, and finally it returns from whence it came by using the JR instruction. Okay, so how about we write a sample program that calls a procedure and uses the stack. Okay, so we'll go ahead and do that. What we'll have is we'll have a procedure that calls 2 other procedures. Okay, and the first procedure will accept 4 integers as arguments, and then it'll call a second procedure which will add up 2 arguments at a time, right? So the first procedure we'll call add 4, the second procedure we'll call add 2, and the add 4 procedure we'll call the add 2 procedure twice. Okay, the first time it calls it, it'll pass its first 2 arguments to the procedure, to the add 2 procedure, and then the second time it calls add 2, it'll pass the second 2 arguments. Okay, so let's go ahead and get started. Okay, so my MIPS program is going to have its text area. Okay, and then at the very end of the program, we're going to have to exit, right? So we'll make a system call to terminate properly. Okay, and then I'm going to have this procedure called add 4. Okay, and then I'll have a procedure called add 2. Right, and so add 2 is going to be called by add 4 twice. Okay, so add 2 is going to look inside of A0 and A1 for the numbers it's supposed to add, and it will place the sum in V0 when it's done. Okay, So I'll go ahead and write the add to procedure first. So what's this thing going to do? Well, it's going to go ahead and do add and place into V0 the sum of A0 and A1, right? And that's all it's going to do. Now add to is known as a leaf procedure, which means that it's not going to call any other procedures. So it's not going to need to create a stack frame. Okay, so it's just going to do its business and then return. Okay, so once the sum is in V0, it's out of here. So it can go ahead and return from whence it came, right? So the address where it should return to is going to be an RA at this point. Okay, so add to, finished. Okay, so add 4 is going to look inside of the A0 through A3 registers for its arguments. Okay, and then it's going to place the sum in V0. Okay, and it's going to call add 2 twice to find the sum of its arguments. Okay, so add 4 is going to need to first create a stack frame, because it's going to need to preserve its return address. Okay, so when it gets called, the address it should return to is going to be an RA. Okay, now the thing is that once it calls add to the first time, the address it's supposed to return to, which was inside of RA, is going to get wiped out. Okay, so we're going to preserve RA. So this stack frame is going to be really simple, right? There's not going to be anything that it's going to need to preserve other than its return address. So let's go ahead and make room on the stack. So we're going to do that by subtracting 4 from the stack pointer. Okay, so that's going to give us a word worth of space on the stack, right? So make room on the stack. Okay, and then I'll need to go ahead and preserve my return address in my stack frame. So I want to store a word with the return address register being the source, and I want to put it 0 bytes away from the top of the stack. Okay, so preserve my return address. Okay, and then once I've done that, I can go ahead and start doing my business. Okay, so first things first, I got to call the add to procedure. Okay, so I can go ahead and do my jump and link instructions since I've preserved add 4's return address. Okay, so jump and link add 2, and the add 4 procedure already has the arguments that it needs to add up instead of A0, A1, A2, and A3. So when I call add 2, A0 and A1 are going to already have the values that the add to procedure needs to do its work. Okay, so when we come back from add 2, V0 is going to have the sum of the first 2 numbers. Okay, so once that's done, I need to move the contents of the A2 and A3 registers into A0 and A1, so that way add 2 can add up those other 2 arguments. So let's go ahead and do that. So we'll go ahead and add to A0 the contents of A2 and 0, and then we'll go ahead and add into A1 the contents of A3 and 0. Right, so that's going to copy the contents of the 3rd and 4th registers into the 1st and 2nd. So that way we'll have our arguments set up for add 2 for the second time. Okay, so once we've done that, we need to make sure that we back up what was returned by add 2, because when add 2 is finished this first time, V0 is going to contain the sum of A0 and A1. Okay, so now here we want to have move into A0 the contents of A2, and here we're going to move the contents of A3 now let's go ahead and back up our V0. We'll put it into the temporary register. So T0 will be where we put it. So V0 and 0. Okay, so what are we doing? So this is going to make sure that the value that was returned by our first call to add to doesn't get overwritten by the value returned by our second call to add to. Okay, so T0 is going to get what was returned by the first call. Okay, so now once we've gotten all that done, we can go ahead and make our second call to add to. Okay, all right, so once that's done, V0 contains the sum of A2 and A3. Okay. Now, when that's finished, T0's got the sum of my first two numbers, and V0's got the sum of my last two numbers. So I'll go ahead and add to V0 the sum of the first two numbers. Okay, so we'll say add to V0, contents of T0. So N0, almost forgot. Okay. So now V0 has got the sum of A0 plus A1 plus A2 plus A3. Why? Well, the sum of A0 and A1 were placed into V0 on the first call. Okay, and on the second call, the sum of A2 and A3 were placed into V0. Right? Before I made that second call, I preserved the results of the first call into T0, and so then I can add into V0. Oops, this should be V0 here instead. So then I can take the sum of what's in T0, the result of my first call, and the result of my second call, and put that into V0, right? So that's right here. T0 is A1 plus A2, and V0 at this point is the sum of A2 and A3. When that addition is finished, V0's got the sum of all four of them. Okay. Now, once that's done, the sum of all four numbers that I wanted to add up is in V0. Add4's job is done, getting the adding done. So now I gotta retrieve the address that I preserved in my stack frame so I know where to get back to. So let's go ahead and do that. So let's load into the RA register the contents of the top of the stack, which is the memory address for where I should return to, or to where I should return to. So let's retrieve our return address, okay, and then let's pop our frame by doing an add operation where we add 4 bytes, or add 4 to the SP pointer to get that word back. So let's restore, or let's pop our stack frame. Okay, and now we can jump back. Okay, and then we'll return. Okay, so this procedure should be done. My add to procedure should be done. Now let's go back to my main procedure and go ahead and call this thing, test it. Okay. Now let's make sure we get this in the right place. Right? We want to terminate the program at the end of main, not after the end of add to. Right? So let's go ahead and put some values into the argument registers. So let's pass some numbers to the argument registers. So we'll go ahead and we'll put into A0, I don't know, 8, A1, 6, A2, 7, and A3, 5. Right, once I've done that, I can go ahead and jump to my add4 function. procedure. Okay, and then once I've done that, when we come back to main here, V0 is going to have the sum. Okay, so V0 has the sum when we get back. Okay, so let's go ahead and display that sum, right? How about I make a little prompt here to tell us what the sum is. So I'll just call this okay. And your total is, okay. So we're going to go ahead and print out that string. So let's load that string into A0. Memory address, the base address for that string. So that goes into A0 prompt. Right, so let's print our prompt, and then let's go ahead and print our value. Of the sum. Now you might have noticed here that I got a problem because the sum was in, remember V0 after calling the procedure has the sum when we got back, right? Then I overwrote it right here with that for. So we'll go ahead and back up the sum to support our printing operations. So let's do that. So we'll go ahead and add, put it in the T0 register. Back up the sum, right? And now we'll go ahead and load it into A0 for printing, right? So we moved the sum that was returned by add4 into T0, freeing us up to then go ahead and print out our prompt, and then we'll get that sum, put it into A0, so then we can print it. Okay. So we'll go ahead and test this. We'll load this thing up into Qt-Spim. Alright, so what did I call it? Example. Okay. Let's see here. I got myself a mistake, so let's go fix it. Where are you? Oh, right here. So this should be an add instruction. So let's try that again. Okay, that looks pretty good. So we'll go ahead and just run it the first time and see what we get. Okay, total is 26. So what values did we use? Let's go back and look. So 8 plus 6 plus 7 plus 5. So is that 26? So 8 plus 6 is 14, plus 7 is 21, plus 5 is 26. So it looks like we have success, right? So total is 26. Awesome. So let's go ahead and go into step-by-step mode just so we can see the registers change and then follow along with what's happening. Okay, so my registers I'll show you in decimal. It'll be easier to see the values. So let's restart this and run it. Okay. All right, so go ahead and get started here. So this line right here, right, you can see in the comments the actual instructions that I typed and what they got translated into right here. So let's go ahead and just go step by step, right? So this first line here is going to put 8 into the argument register. There we go. Next line, put 6 into A1, 5 into A2, and then or 7 into A2, and then 5 into A3, right? So our argument registers are set up. So now we jump down to the add4 procedure, right? So when we do that, the RA register gets updated with the memory address of where we're going to go back to, right? Which is going to be the next instruction. okay, after our jump. Okay, it's going to be this guy right here when we come back. But anyway, so let's continue on executing. So this is structure right here. We're making room on the stack, right? So the SP register changes, and then we store the return address on the stack. Okay. So now if we go look at the stack, you can see that this number right here, top number, matches our return address. Okay, let's go back, continue looking. Okay, so then we did a jump. Okay, after, oops, we kind of jumped a couple instructions here, but right after we made room on the stack and then stored our number, the next instruction was jumping to add 2, and so we did that. Right, so we jumped down to add 2, and now we're going to go ahead and add the numbers. Okay, and once that happened, once we jumped, the memory address of our return instruction updated after the jump to where the add 2 procedure should return 2. Okay, and then add 2 did its add stuff, right? Went ahead and did its adding of A0 and A1, and so then the V0 register got updated. Okay, 8 plus 6, 14. So V0 is the return register. It's got the sum it's supposed to return, and now we're going to go ahead and jump back to where we came from. Okay, so jump back from where we came from, which now we're back into the add 4 procedure, and so now it's time to back up the number that add 2 returned into T0, and now it's time to update register A0 and A1 to prepare our second call for add 2, or to add 2. Okay, so you can see that now 7 and 5 are in registers A0 and A1. So now we're ready to call add 2 for the second time. We're in the add 2 procedure. Return address got updated, and so now we go ahead and do the adding, putting the new value, the new sum, the sum of the second 2 original arguments into the return register V0, and then we jump back from where we came, which is back into the add 4 procedure. And so now it's time to add the contents of T0, which has the original 14, which was the result of the first add 2 procedure call. V0's got 12, which is the result of the second add 2 procedure call. We're going to add those two things together, put them into the V0 register, into the return register. So 14 plus 12, 26. So now the add 4 procedure's done with what it's supposed to do. So we just need to go back to the stack now and get our preserved return address. So that way we know where to jump back to from the add 4 procedure. Okay, so we're doing that with this load instruction right here. Okay, so we've gone ahead and restored our return address that we preserved. Now we're going to reclaim memory from the stack by popping our stack frame. And now once we've done that, we can go ahead and jump back from where the add 4 procedure came. So we go all the way back up to the top here. We're back from the add 4 procedure, and so now we back up our number into T0, so that way it's there for us after we print our prompt. So we have to load into A0 the base address of our prompt string. Then we have to put 4, which is the system call code, into V0 before we make our system call. So we make our system call, and we can see your total is, right? Now we can take the total, which was 26 that we backed up in the T0 register, move it into the A0 register for printing, put the system call code for printing an integer, which is 1, into V0, and then we make our system call. There it is. And so from there, the system call code for exiting the program correctly. 10 is loaded into V0, and then we make the system call and the program's over. Okay, so before I sign off, I'll just bring the code back up here for you to review one more time. Okay, and you can pause the video if you need to see everything, but here's my main procedure. Okay. Here's me setting up the argument registers before I make the jump to add 4. Here's me making the jump to add 4. When we come back, V0 is going to have the sum of those 4 numbers. We back up that sum into T0, so that way we can load it up and print the prompt. And then we get that number out of T0, so that way we can print it, and then we terminate. Now let's look at add 4. Add 4 starts off by creating its stack frame, which included creating room on the stack by doing a subtraction, and then preserving its return address. Then it called the add 2 procedure. Right now, A0 and A1 already contained the first 2 numbers that add 2 needed to do its summing. So when we come back, B0's got the sum of A0 and A1. Now we needed to back that up in preparation for the second call to add 2. Then we took the second 2 arguments, which were in A2 and A3, put them in A0 and A1 in preparation for calling add 2. So once we've done that, we call add 2 the second time, and B0 has now got the sum of A2 and A3. Once we've done that, we take the sum from the first call, which was in T0, add it to the sum from the second call, which is in V0, and then put that in V0. Now we're ready to go back from the add 4 procedure. So we get our return address for add 4 from the stack, reclaim our stack memory by popping the stack frame, and then we return. So add 2 was very simple. Add 2 was a leaf procedure, so it didn't need a stack frame. All it had to do was add the contents of A0 and A1, put it in the correct place, and then go back. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up, and if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.